Number A, I showed that last time. You remember? The last question, I think is you asked 19.1.4. I showed that. I showed that not that how you did that last time, right? The other part is using the sum. So this is basically applying this, directly applying the Parseval identity. Part B is just basically uh, it already given you the Fourier series. X squared is 5 3 4. I mean, you can also check that, but I don't know whether actually need to calculate this Fourier series. Oh. And this is x from minus pi to pi, so the period is the standard case. If you use the Parseval theorem, then they just f this, so this is your f, right? This is your f. Then you plug in the first equation of the problem. So 1 over pi minus pi to pi, and stop to the fx squared, x to the 4th dx, right? So obviously this is elementary. This is just whatever that is. It's actually this is even, so 2 times over pi x to the 5th divided by 5, right? And x to the 5th is pi. This is so the left hand side is this one. The right hand side is sum over all the coefficient of the Fourier series. Yeah. That should be, you have a sub 0 is this one. A sub 0 squared divided by 1/2 is, so pi squared over 1/2. And then plus sum over and 1 to infinity, all the square of the coefficient. But now you only have a sub n because this series doesn't have b sub n, right? So all the a sub n's are 4 minus n squared. And what is that? Right, so this is whatever that is, pi over 5 over plus sum over n. Just work that out, work everything out. It's just 16 over n. And then we wanted to get the zeta 4. I mean, that might be the problem you have. And what is zeta 4? Right? The problem doesn't explain to you, right? Because the ordering of this textbook, so the question doesn't. This is a Raymond zeta function. So that is should be in, I think it's in chapter 14. I mean, chapter 12 also have a section on Raymond zeta function. Or you can look at chapter 12, which we won't actually. Okay, there's a formula in 12, equation 12.67. the Riemann zeta function, the argument is 4, is just, the Riemann zeta function definition is in a little bit earlier, is sum over 1 over n to the s. So whatever s is, so this is sum over n to the 4. Okay. What we have in here, and the answer is given by this equation, which is pi 4 over 90. And see if we got it correctly. So if this is equals to this one, so this sum over 1 over n to the 4th power is this minus that divided by 16. Let's see if this is correct. This is 2/5 minus n18 divided by 5. And now I check that. Hopefully, anyone can do it faster than me. What's that? So I try to multiply together as 5 times 4, 90. And that is 36 minus 5. So that's 31. Oh, yeah. Yeah. You're correct. Yeah. So the definition a sub 0 over 2, right? A sub 0 over 2. So this is a sub 0 over 2. A sub 0 is 2 times that is 2/3, right? 2/3, and the equation, so this is 2/3. Okay. So there's a factor of 4 here. There's a factor of 4. There's a 4 power. And then so do it together, multiply 4, so that's 20. 20 is 16. That is 5 of 4. 16 times with 16 is 5 of 4. Okay. Correct. That is correct. Oh, so I forgot this. The definition a sub 0 is not, I mean, it's different than. Part C is just applying this equation, applying the equation for part C. So it's already given you F x. It's just 1 and minus 1. This is like a square wave. There's is that the other way around? So it's 1 and minus 1, and minus 5, something like that, right? So that's the F, right? And the left-hand surface is quite trivial. F squared is always 1, right? And then the integral will give you 2 pi, and divided by pi, the right-hand side will be 2, right? We apply this to the right-hand side is 2. Now I may actually give you the final formula for the Fourier series, which is strict. Even if not given to you, this is straightforward. You can work out this Fourier series quite easily. So, okay, then the idea is just to sum over all the coefficient. This is all the b's of n. This is like all the b's of n, and then you just sum over all the b's of n square, right? And show this by applying the. Okay, so the right hand side would be, so you want to see the left hand side is 2, the 2 is equals to, so it's sum over all the square of the coefficient, right? So now it's you have all these 4 minus 3, yeah. And now you need to work that out. 16 pi square sum over all the odd, the square of all the odd integers start with 1. So this part is 1 plus the next one is 1, 2, 3, 3 square, and so on. Right? And that you probably need to look it up. I mean, chapter 12 has some series series of this type that already listed. The same section that I just talked about. Do I have that? This is so-called lambda for argument 2. This lambda function, and this is from equation 12. I mean, you can look that up from math table or math handbook also. 12. No, that's 17, not 17. The lambda squared. This is equals to, and this is equals to, there's a coefficient 16. This part is equals to pi squared over 8. So that to be 3. So that is okay. So the last part require you to do some lookup. I mean, I don't know whether there's elementary method to do. I mean, that you can use the method in chapter 12, that section, to do the summation. They give you some technique to do this kind of summation. But it's not necessary for us. You can just look at it. So all these are, you already work out this is given to you. So these are all the sign terms, right? Sign terms or coefficient of sign terms are the Bn, these are n. These are just integer. And whatever you're summing over all the integer or off integer, doesn't matter, because eventually it's just sum over all the coefficients squared. It doesn't matter. You know, whatever the coefficient will be 4 over pi times divided by 2n minus 1. This is the coefficient. So this is the coefficient in front of the sign term. The sum over the square of that, sum over all of them. Okay, that would be the right hand side of the Parseval identity. Okay. Okay, so that is just a check of the, yeah, it's just example how you use the Parseval identity. Okay.